In this video, concepts like degrees of freedom, support conditions, and actual joint rebar provisions on site is discussed. Any RCC building is a framed structure with members creating a grid at each floor supported by columns. Secondary beams are connected to primary beams and primary beams are supported by columns. The type of connection designed by the designer shall be detailed thoroughly and the same shall be executed on the site. It is important to understand the concept of degrees of freedom. So at each joint or support there are 6 degrees of freedom. 3 for translational displacements and 3 for rotational displacements. So here you can see the possible displacement along x-axis, then the possible displacement along y-axis, and finally the possible displacement along z-axis. These are the translational displacements. Now we'll see what are the rotational displacement. Rotational displacement about z-axis, rotational displacement about y-axis, and possible rotational displacement about x-axis. Now let us discuss the types of connections, that is support conditions for joints. So types of joints for a building structure. A fixed joint. In this joint all the displacements with 3 translational and 3 rotational are restrained. But in extreme loadings, joints can rotate, causing damages in case of earthquakes, etc. The second one is partially fixed joint. In this joint, the 3 translational displacements and 2 rotational displacements are restrained, but mz, that is the moment along z-axis, local z-axis, is partially allowed. So members can rotate. The next one is Hinger joint. In this type of joint, the 3 translational displacements are restrained, but rotation about z-axis is fully allowed. And the next is simply supported joint. In this type of joint, the 3 translational displacements and 3 rotational displacements are partially restrained. So only self-weight is sufficient to cause restraint. So now we know the degrees of freedom, the concept of degrees of freedom, and the joint support conditions. So the next step is to discuss the type of joints. So the first one is a slab to beam joint. So slab to beam connection usually appears simply supported, as bars are only resting on the beam bottom rebars and top bent of bars resting or continued up to the next span of the slab. But as they are casted monolithically, the joint is a partially fixed type because slab cannot be rotated independently. If slab is designed as a cantilevered slab, then the top bars shall be embedded in beams with development length. This is the case for a chhajja or a projected slab. So we'll see now the types of joint referring to beam to column. So in this case, if the top beam steel is extended at joint with LD, that is the development length as per the requirement, then the joint is considered as a fixed joint. Whereas if the length provided is less than the LD, then it can be considered as a partially fixed joint. This is in reference with the SP34, page number 104.